Yes, RX. All right, we're in RX world with Bart De Smet. How are you doing, man?
Oh, very good. How about you?
Good. So we talked not too long ago for I guess it would be the RX RP release preview.
Yes, exactly.
And so what's going on today, man?
RTM.
Awesome.
Yes. Yep.
So 2.0 is baked and real.
2.0 is baked. It's real. It works on Windows 8. .NET 4.5. All the good stuff. Yep.
And I know that we had a great conversation, I guess, in 2 iterations back where you dug into portable library work that you've done.
Yep.
I kind of want to revisit that. Portable libraries are increasingly important.
Exactly.
Given the
We've
number of
actually
devices.
gone one step further in RTM, so
You
we
have.
can talk about that as well. Yeah.
Right on. And so, just to get people up to speed, what's the difference between RTM and RTW? So this RTM means you're done coding.
Yeah, we're done coding.
When are people going to get their hands on it?
In fact, in a few days I'm shooting the interview, so so that will be as soon as Windows 8 RTM and VS 2012 RTM are available on MSDN. We'll actually ship RX RTM as well.
Right on. So
and that's RTW though.
That's RTW. So RTW then will be tomorrow.
Yes, exactly. Yeah.
So
tomorrow or the day after. Yeah.
Right on. So when people are watching this, it's either tomorrow or the day after
Yep.
than it is right now. But we know that it's sunny, which is very rare in Seattle. So that's why Bart is in such a good mood today. Me too. You're
I'm
always
in a good mood. Yes.
All right, so let's dig right into this, man. What is new for RTM?
Not that much fundamental. So, we talked a lot about fundamentals in beta and RC, right? And sort of the highlights there were error handling. We improved support for portable library. We did a lot of refactoring of the code. We did, fine-tuning of the way we deal with time. We talked a lot about all of that stuff in the previous couple of interviews.
Yes,
right?
we have.
The final thing we sort of did for RTM was more like shuffling a couple of things around in terms of support for portable library and the build process and those kind of things, solving some outstanding bugs we still had, so a lot of that sort of fine-tuning on the edges.
Excellent.
But there's some pretty important stuff to explain here for the end users.
Great.
And that has to do with portable library. And so maybe I should take you on the historical tour on how we landed portable library for RX, right? So when we did RX V1, it became clear we needed to have RX supported on many platforms. So we started even before there was a TPL, right? And we did a backport of the TPL back in the 3.5 days. But so we had .NET 3.5, later we had .NET 4, we had Silverlight 3, 4, and 5, Windows Phone 7 and 7.1. You can already see this thing getting out of hand in terms of the number of copies that you have to maintain. And so, as we started to work on V2.0, somewhere last holiday season, I started doing all the performance work, and it became clear, well, we have this other platform now, Windows 8, and we have .NET 4.5. So there's a lot of stuff here, and maybe we should consolidate, because now the portable library stuff is also getting real in VS 2012. And so we did some refactoring of the assembly surface to actually split out the platform-specific capabilities from the ones that are actually platform neutral, I would call it, and that can be portable. And we talked a lot about the mechanics by which we enable this in terms of platform enlightenment, so that we have a portable core and then it discovers some platform specifics at runtime. So there was a lot of work going on in there. Now, as we were going through beta and RC, portable library was still evolving as well, right? Some things weren't yet in the intersections because they had to sort of move a couple of things in .NET 4.5 to make it intersectable between different target platforms. And so it was sort of like a moving target. And so at the point we did beta, we ended actually not up having less assemblies, we ended up having more assemblies. We ended up having a .NET 4.5 build, a Windows 8 build, and then we also had a portable build. And so we had those 3 things sitting next to each other. And then maybe I should throw some pictures here. Right?
That would be great.
But just to sort of land it first in words, the problem sort of was, well, if we're going to move to portable library as the core of this, we darn better make sure that those enlightenments are actually present at runtime, because otherwise you have a slower RX, because it can only use things in the intersection of the framework. And so the intersection between, for example, 4.5 and Windows 8 is well, there's a different thread pool. So you can't choose any thread pool in your portable library. You have to sort of go to defaults, and defaults are based on task of T, which works totally fine. But if you have high volume streams and you want to allocate a task on a per message basis, for example, to delay things or whatever, to do task.delay, well, you actually end up having a very suboptimal situation, because you have a lot of timer objects that are allocated by tasks that are, being allocated in general. And so ideally, to do things like periodic timers, you don't want to have recursive task.delays, which is like just giving a lot of food to the garbage collector. You want to have a system threading timer or a WinRT thread pool timer. And so those cannot be in the common intersections, so we have to discover them at runtime using those platform enlightenments. And so the packaging format wasn't completely done yet in beta. We didn't have the extension SDK model worked out totally well yet. So including Rx became like, don't forget to select this assembly and don't forget to select that one in order to get the best performance. And so in RTM we can actually solve a lot of those things thanks to the extension SDK being completely done. And so we'll talk about the extension SDK in somewhat more detail as well. But long story short here is, as we sort of moved from beta to RC to RDM, the differences between the portable intersection, so the portable build of Rx, and the Windows 8 and .NET 4.5 specific builds became really, really very small. And at some point, we also hit some little issue as we were actually testing some scenarios where people use a portable library project using Rx, as well as a Windows 8 application using the extension SDK. Things started failing at build time, and I will explain why that was. It was kind of a subtle thing. But at that point we said, well, maybe you should do the full thing now. And so we pulled the trigger on portable library in a positive way. We said like .NET 4.5 and Windows 8 builds that will ship in the SDK are based on the portable library. There are no platform-specific builds of the core of Rx anymore for those two platforms.
Great.
In the past it was like an opt-in model. We said there's too many differences still between our portable story and the platform-specific story that maybe to make the migration path for people as smooth as possible, they should start with the platform-specific ones and then explicitly opt into portability. And that's sort of like dragging your feet a little bit longer, right? And like, I wasn't completely pleased with that situation myself. And secondly, we sort of want people to go onto the portable train as soon as possible, because we have, new releases coming out, later this year or next year that will include like other platforms. Like for example, next version of the phone will come out at some point, and you will get portable library support for that one as well. That's where we want to go. And so if we sort of postpone the going to portable, then maybe next time it wouldn't still be completely aligned yet, and so on and so on. So we rather front load that work as opposed to sort of like drag feet. And so the nice thing about this is everyone using Rx on .NET 4.5 and Windows 8 will use portable libraries some way. You don't have to see that if you're just building an app, but as you start refactoring pieces of your code and you want to reuse it between, say, a WPF app, a Windows Forms app, a console app, a Windows service, an ASP.NET website, and a Windows Store app, or a Windows 8 app, as you want to refactor all of that stuff, well, you can put all of the common code in the same assembly, which is portable across those two platforms.
Excellent. Yeah. It's something that's occurred to me as well. I mean, in the Windows 8 specific, I mean, in some sense, nothing is stopping somebody from writing a, in this case, C#. You could use VB as well, but a C# WinRT component, which is basically an Rx component. That JavaScript and C++, especially in this case, since you guys haven't released that C++ RX yet. I know Aaron's very busy.
Yes.
That would be a kind of seamless way, because of the nice interoperation built in by the Windows runtime between very different runtimes and languages. So have you seen anybody doing that?
We've actually seen a couple of early, attempts at doing it, and it actually worked out pretty well. The only thing to be aware of, as you build like a WinRT or a WinMD file, right? Windows runtime component, is everything on the public surface needs to be subject to certain rules, right? Like can only have like sealed classes and things. And the same thing holds for generics. Like generics are limited in the sense that you can't define your own generic thing that you expose, but you can consume ones that are defined by the WinRT APIs. And so IObservable of T is not in there. And so like at the boundary of marshalling there, you sort of need to loosen up the typing, which is fine if you go, for example, to JavaScript, right? Like you say, I just want to have an IObservable without a T, and we don't have that interface today. Maybe at some point we should, for interoperability reasons. But so what you're doing is you're sort of untyping the thing, and then you can sort of like send it over to the other end. And ideally, you could even bind Rx for JavaScript against something that comes out of the other world, right? Like, and that's something that's actually doable with very little plumbing. Unfortunately, there's a little bit of plumbing to do because of the interface restrictions and so on. But once you're on the other end, like you can consume that stream in a traditional way using JavaScript functions, or you can also do it to the C++ side.
Well, I mean, in some sense, so for JavaScript, you can't write shared WinRT components in WinRT.
Yes. But you can consume them.
But you can consume.
Yeah, exactly.
But I mean, if I have an app and I want to take advantage of sort of the asynchrony that Rx affords,
yes,
you know, just calling into a library that I pass either a pointer to data or I pass a data set or whatever and have it do its thing on it. You know, maybe it's just a pointer to a stream of information that's going to come down, and you do, when you're done, you just send me back that you're done. So it's an asynchronous operation. Rx does its magic.
Oh yeah.
That said, one of the nice things about Rx is the semantics in your face in the code that you're writing.
Yeah.
And of course, you wouldn't get that from the caller wanting to consume. So something like C++ wanting to consume an Rx component wouldn't have that nice sort of linkified experience.
Exactly.
But they will in the future. Anyway, I just wanted to bring that up because WinRT does afford this notion of really interesting component model. Right? Basically, it's calm, man.
Yep.
So you can write these cool WinRT components that you define in WinMD.
And in there you can
rock and roll.
Rx actually. So.
All right, so it's time to get Bart on the board because it's board time with Bart.
Yep, perfect.
So let me get this thing up, and then looks like we got a little bit of erasing to do.
Oh, as usual, you know. Always very.
You have a lot of stuff on there, man.
It's a traditional kind of thing. Alright, so let's talk portable library first, and before we forget, we also need to talk a little bit about experimental. Like, you know, the whole experimental stable split that we had before, we changed that as well.
You did?
To actually be much more easy to adopt. And
cool.
We'll talk about that as well. But so, to do just a little step back of where we are today with Rx, right? The supported platforms include 4.5, Windows 8, Windows Phone 7, what else? Silverlight 5, and then we have this whole portable thing as well, and we'll talk about where that sits. And so if you actually look at the beta timeframe, in the beta timeframe we said next to this whole set of things we also have portable libraries sitting there. And so just to explain how things sort of panned out there, let's make this thing into a matrix of the assemblies that we sort of had in the different platforms. And so, as we discussed before, RxV2 has been split up in more assemblies to actually allow you to deploy only the things you need, and also to split out platform specifics from platform neutral stuff. And so we actually have, I will abbreviate them, we have an assembly called interfaces, system reactive interfaces, something called core, system reactive core, which contains base types and scheduler, you know, infrastructure kind of things. Also platform neutral, by the way. We have link, which is where the query library lives, and sort of the way to think of this is really, if you've seen recent presentations of Rx, we sort of talk about those three layers as well. We have sort of the runtime layer, which is the core layer, and then we have the query engine layer on top of that. And so people spend 99% of their time in the link layer, and they don't have to care about the other things. So that's what classically used to be system.reactive. So it's been split up. And this also allows you to define, for example, contracts on the interface level without needing the core level. And if you just want to synchronize with UI threads, for example, you just need core and you don't need link. So you can sort of do this incremental kind of thing. So that's one set of assemblies. Then we have providers, which gives you the IC observable stuff. And by the way, there is some very beautiful project online right now called Pushka. And Pushka is actually a guy who took up the IC observable stuff and said, let's expose it as an OData endpoint using the OData language. And so you can basically have your event stream somewhere in the cloud, and then you have this thing called Pushka. Don't know whether I spell it exactly correct here. PushQA, I think it is. And so what basically sticks out of that cloud is something that talks the OData service language, like the OData query language. But what you get back in your SignalR client, for example, is essentially a stream that can come back over WebSockets or whatever transport you want. And so as you're writing a query over here in either RxJS or Rx.net, you can basically write, for example, a where class and say, like, from the stock exchange over here, like this is some stock tick service, I want to get only NSFT. And so your predicate basically travels to the Pushka service, and here it basically binds to the iObservable. And then you get a session back that's just doing the filtering for you.
Awesome.
And so so that's actually how we envisioned iObservable to be used in the first place. And in fact, like, Stream Insight version 2.1 uses a very similar mechanism to remote entire Rx queries into the engine. So, observable took a while, but you see people start to grok like what it's about and how to use it.
So Stream Insight is using IQ Observable?
Yeah. Stream Insight 2.1 you can actually host reactive queries in the engine. So,
awesome.
So if you want to have hosting for Rx queries, you can use Stream Insight there.
Great.
Yep. So
nice to see IQ Observable again.
Exactly.
It's been a while. That was an epic whiteboarding session.
Oh yes.
People should go back and watch that.
I remember that one with the 4 quadrants kind of thing.
Yeah.
Good.
Cool.
So that's providers.
All right.
And then we have UI specific ones, right? We have Windows Forms. We have Windows Threading, which is the same name used for Windows 8, Windows Phone 7, 4.5 and Silverlight.
Okay.
And then we also have over here runtime, not runtime, remoting, or remoting.
Okay.
And then we finally at the very bottom have system.reactive.windows runtime, which is Windows runtime specific interop library. So quite a few things, right?
Absolutely.
And now, as you look at this whole picture, I need to set some interesting, fill the matrix a little bit, to sort of show like how things looked before our final refactoring. So for 4.5 we basically had, of course, those 4 guys, platform-specific builds. What that meant is, for example, in the core scheduler infrastructure we could use system threading timer, like because it's available in the 4.5 build, right? Then we have providers that supported, Windows Forms is supported, Windows Threading for WPF is supported, and remoting is supported. Only WinRT is not supported in 4.5 for the desktop. Right? Then you have Windows 8, same story. You have those first 3 guys over here. You have a providers assembly. You don't have WinForms, you have Windows Threading, which uses the new Windows XAML stuff. And you have WinRT at the very bottom. Then you have Windows Phone 7. You have those 3 guys, interfaces, core and link. You have providers for expression tree support. You don't have WinForms, but you have Windows Threading, and you don't have remoting either.
Okay.
And then for Silverlight, it's basically the same as Windows Phone in terms of the matrix. And we also have a test library. Let's ignore that one here, because it's not a runtime thing. And then we had portable library. Actually, let me do portable using a different color here, PL. It basically had the first 4 in a portable form. Okay?
Mm-hmm.
And so, of course, the question is, first of all, what does portable library support here? And we talked about that one before. Our portable story is 4.5 and Windows 8. 4.5, .NET Framework 4.5, and Windows 8 is really .NET Core 4.5. That's how it's called in the reference assemblies folders. So if you notice this, that's basically what it is. So that's the 2 things we support. So the obvious question is, why do those things over here not use the portable assemblies instead by default? And so I already alluded at it, like for example in here, this guy said, I'm going to take a dependency on the timer. I'm going to take a dependency on the WinRT thread pool, and so on. And so that gives like specialization, which gives great performance, but no portability. Secondly, if you look at our API service, we have things like scheduler.threadpool, right? That's one of the static properties that's defined in System Reactive Core. We can't move that to a different assembly because then we have to lose other methods on scheduler in the core, and then the core is empty. Like then you don't have to have a core, and things start to fall apart. And so thread pool you can't do in a platform neutral way because there's no common thread pool. There's the CLR thread pool queue is a work item, and you have a very similar API in Windows 8. So it doesn't quite work. And so we said on those platforms we'll still have those properties, but we'll put the deprecated attribute on top of it. Okay. And so as you compile it, will basically tell you, in the future, start using those libraries differently. And the answer to that was, we basically insert a little assembly, and I don't have enough space over here, but we actually insert an assembly called platform services, which basically provides platform-specific capabilities for all of those platforms.
Great.
And that's not in the portable subset. So what really happens is at runtime, this guy, the core guy, searches for platform services to enlighten itself about what's available on the platform. For example, what the thread pool is. So why did we still have the two different things, right? Why did we still have this? Because the idea was you start with the head assemblies, which are platform specific. You get those deprecation warnings, but things still work out. And you deploy the platform services alongside of it to complete the picture. And you can work without platform services. Things just run a little slower in certain cases. Now, the theory was as follows. Once you've done this and you want to go to refactor some of your code to become portable, you can basically replace those red crosses over here with the green crosses from portable library. With one little caveat. In portable library, because it's our very first release of doing portable library, we said, you know what, maybe we shouldn't have things deprecated right over the start inside this library. Like, we don't want to have scheduler.threadpool in the very first version of our portable library that says, it's version 1 and we're already deprecating this thing. Like, doesn't quite make sense to people. So that was sort of the difference ultimately between those platform-specific builds for 4, 5, and 8 and the portable library one was, this one was kind of cleaned out a little bit. Secondly, it also worked around some of the issues with the release candidate and the beta of Visual Studio 2012, where things weren't completely worked out yet for portable library. It was still in progress. And so as we looked closer to RTM, the differences between those assemblies became so small that really the only thing that was still there was the difference between what was deprecated and what was not. Right? Like, the deprecated stuff would be in those red cross assemblies, but they wouldn't be in here. And then, like, if that's the only difference, we're sort of putting this whole problem onto a lot of people to say, like, start with platform specific, start migrating your code to get rid of those deprecation warnings by including platform services, and then you can include portable library. Like, didn't quite work out. So, what we said is, we're actually gonna do the whole swap right now. We're gonna say in RTM, those guys use portable, oops, that's the wrong color, in my color. All of those guys use portable library. So if you actually look in the SDK installer of RX, you will actually find that in the .NET 4.5 and the .NET Core folders, you will find copies of those assemblies. The MSI will install them in different locations, but if you do a comp command on them to basically compare those files, it will say they are byte by byte identical. And also the ones in the portable library subfolder will also have exactly the same commons. So that's actually what ends up here. Now, the thing is, you still need to make sure that those platform services are selected.
Okay.
Because if you don't run with platform services, the thing in the portable subset can only use things like task.delay to create a timer, which is a lot of wrapping around a simple timer. And so what's really going on now is you need those platform services to really get the best performance, just like you did in beta and RC for RX. Now the beauty is that in a lot of cases you don't have to select those things yourself. Only if you go to the classic add reference dialog, you will have to pick those guys. You will have to say, I want to pick interfaces, core, link, and platform services. Those 4 guys to get started with what used to be system.reactive. However, if you use NuGet, for example, and you do rx.main or rx-main, this thing will automatically suck in the platform services for your platform. So you don't have to worry about it. If you're on Windows 8 and you're using the so-called extension SDK model, you just have one checkbox to check in the add reference dialog that says reactive extensions, and it will include all of that stuff for you.
Great.
In fact, the extension SDK will include interfaces, core and link, platform services, all of that stuff, as well as Windows threading and Windows runtime. So you actually get observe on dispatch, or you get interop with IAsync progress, IAsync info, IAsync operation, all of those guys. All of that stuff is readily available. The only thing you have to import is the namespace, system.reactive, whatever.
Yeah.
Right? And then you get all of that stuff. So a single checkbox for a single RX package that you have to download.
Great.
And so what this allows you to do now to sort of like erase this thing and give you an overview of a typical end-user scenario is you can actually start building applications that depend on a common portable library core. So you can have this kind of situation. You can say, you know what, I'm building, let's start at the top actually. I'm building 2 apps, right? Or let's say I'm actually building a WPF app to start with, okay? And I have my XAML stuff sitting here, and I have my C# or VB code sitting here, right? And this thing actually uses some of Rx, okay? So I'm just gonna do a reference in red to, Rx 4.5, for .NET 4.5, like Rx 2.0. And so you have those things sitting here, and in fact that will actually suck in at compile time. It will actually include for you interfaces, core, and link in green, because those are actually platform neutral, those are the portable guys. It will suck in platform services, which is this enlightenment mechanism. It will also add over here in red Windows threading, which is observe on dispatch. So that's what you basically get if you include Rx. Say you include Rx-XAML, which is the one-stop shop for anything that's XAML based, Windows Phone, Silverlight, WPF, and Windows 8 apps. If you include RxXAML, you get this set of assemblies.
Awesome.
So you have this thing sitting here, and you're actually building some Rx code. And a lot of the Rx code you're actually building here is green code, it's portable code. Okay. Now you say we want to go to this new thing called Windows 8 XAML applications. So let me actually port this whole thing. Okay. And it's as beautiful as this, like copy your XAML over, works. Copy over your C# code, works if you're not using very platform specific things of the CLR here. The CLR is still there, but it's a subset that's available. So say that your code here would use threadpool.q as a work item, you would have to replace it over there. But so you're basically copying those things, and we actually have a porting guide somewhere on MSDN on, like, if you have a .NETism that doesn't work here, what the equivalent is in WinRT. And it's a rather short list actually. So it's pretty easy to port all of that stuff. And then you would include over there your reference to Rx. So you would actually include a reference to Rx as an extension SDK from the dialog. Okay? What that gives you is, again, interfaces, core, and link. You get platform services, right? And what you get next to that is 2 more things. Windows threading, WT, and Windows runtime, which is system.reactive Windows runtime, which gives you interop with IAsync operation and all of that stuff. So we basically get all of that, those things included. And again, you would simply also port over, copy over your green code that uses Rx over here, right? So as you do that, you now have created a Windows 8 app by very minimal effort.
That's awesome.
However, we've copied a lot of code. Right?
So all of your Rx stuff can be compartmentalized into something that is just, the porting is really just copying.
Exactly. Yeah.
Awesome.
And so now the question is, say you want to maintain both apps, right? And in the future, like, you know, you will have something else sitting here, like, you know, Windows Phone v Next. I think we now officially call it 8.
Windows
right?
Phone 8, yeah.
Windows Phone 8, so, you know, you will have a Windows Phone 8 app sitting there as well, and you can again start porting some XAML and C# and VB and common code. Like, now I have 3 apps to maintain. For my classic desktop users, for my, you know, Windows 8 full screen immersive application users, and for the Windows Phone 8 users. Like, can't I just copy some of that code into a portable library is the question. And the answer is absolutely. So what I'm gonna do is I'm gonna create a portable library project over here, right? And now I'm gonna start moving things down. So I'm gonna take this RX code and actually move it over here, which was an identical copy of that guy. So I can remove those two, okay? Of course, I also need to add a reference to the portable library. So I'm gonna add a reference. Well, actually, let's assume this green thing is basically the reference arrow now. Like, you know, no longer the copy arrow. What's really going on now is this project is referenced by those 2 projects in Visual Studio. And then over here, what I include is the portable interfaces core and link from the add reference dialog. And at that point, you can just compile this whole thing and take away those green boxes over here. You could also start taking out some of that C# and VB code that's not platform specific, so you could actually start, you know, porting, like if this was like all the C# and VB code that's sitting there, C# and VB code that's sitting there, say you had like some portable chunk of it, right? You could also move that thing out here. And so basically you move it over here and over there. So in the original model that we had where those things had only platform specific copies, things kind of worked out, but they didn't work out. Like, what do I mean with that? So that's before RTM of RX, like this is how it works today. But before RTM we said, if you include RxSample or RX main over here, and you include the extension SDK over there, the 3 guys you get on the top, the portable guys, would actually be not portable. You would actually get RAD assemblies, platform specific ones. To an extent that you don't even need platform services to be optimal, because it can depend on platform specific capabilities. Now the problem that we found in RTM was, now say that somebody builds a portable library here, right, that uses the portable 3 assemblies over here.
Okay.
And say that we would actually have platform specific Windows 8 assembly sitting there, interfaces core link, as opposed to the platform neutral ones. That was the RCM beta model of RxV2. What happened at compile time was this. MS build says, I need to build this guy. I'm gonna suck in everything from the extension SDK to my layout folder, to the appx folder. That ultimately is the thing that gets packaged up and sent to the store, right? So it copies all of those assemblies, which means I have ICNL, interfaces core and link, platform specific. It also needs to traverse all the references to other projects. So it starts building this portable guy, and this guy says, I have a plib.dll file, which is my DLL here, my class library, as well as those 3 guys over here. Let me also copy those to the appx output folder. And now what happens is I have 3 green ones and 3 red ones in the same folder. And MS build says, or the build task for appx packaging says, I have 2 files with the same name in my output folder. What it doesn't know is that the green ones could totally be overwritten with red ones, and that would still work at runtime. We actually tested for that, because remember, the green ones are just the red ones without all the deprecated stuff. We just stripped it out originally. Like, one is purely a subset of the other. So like if you look at the green thing here, like the portable ones, and you look at the red ones would be exactly the same, but just with a little bit of additional stuff here for backwards compat. So at runtime it would totally work fine to take the red ones, because they're a stacked superset of the green ones, and everything would still work out. But MS Build doesn't know that. It sees 2 assemblies, same name, different file sizes. It doesn't start looking at the metadata in the file. There's no way to say this one is a superset of the other assembly. Like, that kind of construct doesn't exist. So it didn't work out. And so we said, like, look at this thing. Like, this is literally just, you know, like 10 members or something the difference. Let's just sketch that all together for Windows 8 and Windows and .NET 4.5. Let's say we only go for green. So this goes away. And now at build time, when this thing compiles, it gets those 3 green ones. When this thing compiles, it gets those 3 green ones. They both go to the app.x folder. And it says, I still have 2 files with the same name. But then it says, let me take a look at the length of the file, as well as the last write time of the file. Oh, they match. They have to be the same copy. And so then the build actually succeeds. So if we didn't do that, everyone had to sort of throw away the extension SDK model as soon as you use portable. To use a portable library, you would have to replace assemblies manually, and like things were too complicated.
Sure.
And I could see like long blog posts and forum discussions coming up, like explaining how to use it. And
well, that's awesome.
Not worth it. So we said, like, let's just go all the way for portable. And so this only stretches to Windows 8 and .NET 4.5. We didn't include .NET 4.0 for reasons we explained in the beta time frame. Namely that by including 4.0 you lose things like exception dispatch info. You lose task.delay, so you don't have a common way of actually doing timers. And so you lose too much by also trying to include something from the past.
Now the question I have right off the bat related to that, for the .NET folks out there, I mean, 4.5 is an in-place update, which means everything in 4 will work.
Exactly. Yeah.
So in some sense, that's sort of, if you have a bunch of 4.0 code, now granted, if you're using the RX 4.0, there may be differences in the RX you're using. But that's actually a good question. If I have a bunch of stuff I've done in 4.0, because it's released, and I have this shipping RX project.
Using RX 1.0.
Yeah. Talk to me a little bit about migrating and porting and upgrading to the latest and greatest.
If you're using NuGet, no problem whatsoever. So you will basically get an update to whatever mechanism they have. You'll end up with like 2 or 3 more assemblies in RX v2.0, but things should still be compatible. The only places where we have some breaking changes are places where the semantics were not confirm what we wanted to do. Like, for example, exceptions were dropped on the floor. Like, if you rely on behavior of an exception being dropped, it's going to blow up in 2.0. Like, the exception is not going to be dropped. Some other things, like, you know, the way we do timers, for example, as we explained in the RC series, in a lot of detail. Exactly. Like, if you relied on things to set your clock by, because like it was aligned with absolute time, that wouldn't longer be the case. And so we'll actually have some guidance on how to port those things if you really want those guarantees. Then you will have to change a little bit of your code. But other than that, it's a totally compatible API. Some things may be deprecated. Things that are too blocking are deprecated, but they still work in this release. In Trio, we may take them out, right? As we always do with obsolete and deprecate functionality. But yeah, so porting should be relatively easy. Actually.
Now, of course, the only thing about RX, and I think this is true for any technology that is constantly evolving and building towards an RTM date, the documentation has been less than stellar.
Yes.
And I think now that you've RTM'd and the bits are baked and the model is baked and you're convinced that this is the right way to go, can you tell me a little bit, and for people out there as well, when are we going to start seeing a rev of the documentation?
So we're actually on that. So first of all...
and wait, just so people know, you're looking at the RX team. Okay?
Sort of, yes.
Yes. So I just wanted to say that. Okay, continue.
So first of all, the XML documentation in IntelliSense has been expanded very significantly. So that's something we started doing in RC. In RTM we did the extra mile. So we have much more operators that have like a remark section with some interesting tidbits or trivia or caveats to point out. We have all the exception behavior is documented, which is kind of interesting because you have this exception tag in XML doc comments. And they really only apply to synchronously thrown exceptions, like argument null exception, argument out of range, and those kind of things, which are trivial, but we added them anyway. But you also have in RX asynchronous exception behavior, right, where you say, like, I'm doing single, for example, single async on a stream. So that thing will eventually, when it sees the uncompleted message, give you the single value that we saw in the stream. But like if in the stream there were two messages, at the point of seeing the second message we say, wait, we are not alone here. Like, no, this is not a single element stream. So at the point of seeing the second message, we would actually send out an invalid operation exception saying this thing has two values in it. And so what, they're cleaning the windows here.
Yeah.
Like, so what's really going on is the exception doesn't come out synchronously. It actually comes out to the on-error channel, so we documented that behavior as well. So we have much more documentation going on there. Then next we'll actually do a lot of blog posts initially on like the different aspects of RxV2. And we're also working with the doc team, because like Rx is being used by much more internal teams, we can sort of share the effort of actually mostly outlining patterns, because like the API documentation is there now. What people really look for is patterns. And we could either give them cookbooks saying like, in a UI application do this, that and that, with some samples. Or we could explain them the grand scheme of things, like when you start publishing streams, for example, to share side effects and all of those things. And so that's the next step documentation, is like really explaining how you should structure your code when you use Rx. And then some pretty concrete examples as well. Like on Tagged I did a demo of using Rx for Kinect. We'll make a blog post out of that. And so those are the simple 20-line pieces of code to get people started and sort of whet their appetite.
Totally. I mean, and there's also stuff that the community has done around. It'd be interesting to see how the 101 Rx scripts, how that evolves to meet the new stuff that you've done. And there's also a relatively large volume of information out there not written by you. Of course, you're the definitive source. But that's all going to have
Lee
to...
Campbell, for example, just to point out one guy, he has an online Rx book, which has like, 10 chapters or something with very valuable information. And
Great.
most of it is completely relevant to RxV2 as well, because of the compatibility rights. So.
Perfect. Now you mentioned, I think, to finalize this, let's talk a little bit about what it means. Did JavaScript, so RxJS v2 RTM also?
Yeah, we're actively finishing up that work as well.
Okay.
So in the next few days, we'll hit RTM for that one as well.
Great.
Yeah.
And then
including WinJS bindings, for example. So,
awesome.
Yeah.
That's very important.
Yeah.
Now the other thing is, you mentioned you've changed the way you deal with experimental builds.
Exactly.
What does that mean?
Okay. So one more picture on the whiteboard here, and in fact, like this, I can show you on the laptop, concretely working.
Okay.
Like two XAML-based applications using a portable library using Rx. So we'll just show that at the end of the interview really quickly. But so the way we changed experimental is this. So what we had in the past was this model, right? So this is the timeline. Okay. At some point we had Rx 1.0. Let's even not go to the pre-releases that we had, right? And we came to the conclusion, well, there's quite some stuff in Rx here that's really still experimental. We're still working on that. And so sort of at the same time, we released this Rx 1.1 as well.
Okay.
And so what really happened is you had 1.0 sitting here, so that's system.reactive 1.0, and then we shipped, shortly after we said like Rx 1.1, may actually have been on the same build date officially, we shipped this guy, and what really happened was like this thing was slightly taller in some sense, so it contained more stuff, but you basically had new copies of system.reactive and other assemblies. So you basically had to toss out all of the Rx stuff you were using and substitute it for 1.1 binaries. Now, what's really going on internally in those guys, in those experimental ones, was that we just sort of add things at the top.
Okay. Some
additional operators and stuff. But you cannot really trust it in some sense, like as an end user. Like as an end user you say, I have system.reactive and this one is supported, we actually have contracts with CSS and so on. You can call in and say we have an issue there. And now I have to deploy Rx 1.1, which is not stable, which is experimental. And even though internally it may just be additions, who says that there weren't subtle changes in the core of Rx as well? Because I'm just substituting a binary. I can't see that it's a honest layering inside. And so you had to sort of toss out, just to get some additional members here, you had to toss out the core thing as well and sort of like lose supportability and all of those things. And so this thing continued moving actually and sort of continued growing a little bit more and so on, and so you had all those experimental guys. So in 2.0 we say you want to go for a different model. In RX 2.0 we actually ship System Reactive Interfaces core link as well as providers, which is the observable stuff, right? And now we say, and then you have the platform specific guys as well, right? You know, you have Windows Threading, Windows Forms and all those. And we say for experimental, we basically give you system.reactive experimental, which sort of sits totally as an external assembly on top of that. And it can talk to all of those layers as well. But so there's no changes inside those layers. So you just have an additional model. And this one actually doesn't exist in the MSI at all. It only lives on NuGet. So you can just go to NuGet, import rx-experimental. And that actually has a dependency on RX main, which is the 2.0 build. And then this thing will also be the experimental one, will be 2.0 and then some number that's larger than the 2.0 number over here.
Sure.
So this number, normally the final build is 2.0814, that's today. So that's the final build number of RX RTM. Depending on when we actually push, we may actually have 15. So like it may be off with 1 or 2 at most. But then like the experimental guy will initially start with the same number, but then that thing will just move up independently.
So in reality, I mean, how have people been leveraging and using, and let's be honest, downloading these experimental builds? You see a lot of interest in that?
Yeah, it's sort of like, it was 50-50 to some point, because like people said, we want to have the latest and greatest all the time.
Okay.
And some people are more like, you know, we just want to have the stable functionality. So the downloads on NuGet were pretty similar.
Excellent.
In terms of numbers. One thing that came out of this is, because we are splitting across different assemblies, you can't have the same type name in 2 places. So you can't have system.reactive.link.observable in here and in there, because then it conflicts. So what we did is, like in here, the place where we define operators is observable EX, and EX doesn't stand for extension, it stands for experimental. Like now I have a reason to explain what EX stands for.
Great.
In the past we had core EX at some point, and like, what's that thing mean? But so EX is really experimental here. And so that's where we actually put all of that stuff. Providers has the same thing, but then observable EX. But all the things that actually had to change usage patterns based on the rename have been moved into stable. And so things like if, case, do while, the imperative set of operators, all of those guys, actually are unstable because, you know, people were using them as observable dot, right? Observable.if, and now it would be observable ex.if because they're not extension methods. So they actually moved some of those originally experimental things into the stable subset because those are really very small operators, and actually I've seen them being used more than I expected to originally. So that's actually a good thing. So a lot of people are using them. They're also in Windows Phone 7, by the way, built in. So taking them out of the observable surface makes, towards the future, people porting their Windows Phone 7 apps to Windows Phone 8 using RX that's not in the ROM but actually downloads from NuGet. Like that migration path to the latest and greatest RX v2 to sort of go out of the ROM and sort of go to the NuGet latest would be hindered if people were using those guys. And in fact, like from some of the telemetry data that we actually had in the Windows Phone 7 store, like, you know, we had a lot of compat kind of things to look at for Windows Phone 8. Some of those actually ended up with me to say, like, this looks like, you know, something in RX has changed that makes this application not work on Phone 7 or on Phone 8. So I had to look at those things, and, you know, we resolved those issues. And in the largest case, it was underlying platform issues were still being addressed in the build there. But I noticed a couple of places where, you know, if, case, and do while are used. Like as I was setting breakpoints in the RX code on the phone, and actually some application, third-party application was running, I noticed that those guys were used in quite a few places. And so there were some common libraries that I identified that people had created for all of their phone assets. And so like some people have like 20 apps in the marketplace and they all use the same library underneath to do some coordination of event streams. And they were using Rx and they were using some of those imperative guys. So like just taking those out wouldn't be the best thing, right?
No, not at all.
Or changing the way to access them using the EX suffix. So that's how experimental looks now. It's just an additional DLL, which means you can still rely on the stability of the core. This thing cannot destabilize.
Excellent.
What's on top of it or underneath it. Yeah.
Cool. Well, let's finish with some code.
Yeah. Good. Let's actually, oops. Here we go. So, this is where we started with, right? Like, you know, the initial shot.
Yes.
Yeah. So, what I have here is actually, let me show you the project structure, and maybe not big enough to actually see it from the back there, but what I have here is 3 projects really. I have a Windows 8 demo app, I have a WPF demo app, and I have a portable library. Okay? And they follow the structure that we explained on the whiteboard. The Windows 8 and WPF app actually both refer to the portable library at the bottom. And so for the Windows 8 app, the way I included Rx was really by doing add reference here and basically use Windows extensions where you find the extension SDK. So it's a single click to actually include it.
Great.
So that's very easy. In WPF, the way I did that, that's a .NET 4.5 app, I actually used the NuGet package manager to basically include over here reactive. And by the way, the logo of reactive is actually blending in nicely. We made it, you know, grayscale to
awesome.
Basically fit nicer in this dialog. Otherwise, we were the only ones looking pinky or whatever.
Okay, sure.
So that's what's going on there. And then I have the portable library, which actually includes the .NET portable subset. In fact, like this guy is actually built over here using portable library targeting only 4.5 and .NET for Windows 8 apps. So those 2 things you actually need to include there, nothing else, because if you do anything else, you fall out of that common intersection. Now the beauty is that this is the future-looking platform. So 4.5 and 4.5 for Windows apps, Windows 8 apps, is actually the platform that will also be shared, the .NET Core, with future releases. So it's the future-looking thing. And so that's what we have there. And so what I really had originally is, let me actually boost the font size here a little bit. That's my WPF app, or my Windows 8 app. And so I had the classic kind of Rx thing sitting here. I had like some input using from event pattern, getting things from the text box. And I did total and distinct to basically slow down the event sequence. Like if the user is really typing fast, we've explained that a lot of times in dictionary suggest samples and things, like the recipe there is to use total and distinct to make sure you can't have adjacent duplicate values, and that if the user types fast, you're not flooding a web service or something, so you want to throttle it down. And then I have some query sitting here, which is really sort of talking to the web service. I'm just mimicking the web service here using task. So a task that delays to 50 milliseconds to give me the answer back. Like in reality you would talk to a real web service or something. But so I'm really joining user input here with computations. And so this is one of the nice syntaxes that we actually have in RxV2, is you can just use from select, like, you know, this select many in disguise, using task objects here. In fact, you can also have async operations in your query syntax here. So if you have a WinRT API that returns an async operation from a web service, you can just use from something in my observable sequence, from something in the response that's returned as an IAsync operation.
Great.
So you can just blend those things together. So that's what I have here. That's my core logic in some sense, and it returns like the length and whatever. So it basically will print, if I type Rx, it will print Rx.length equals 2.
Okay.
And so next what we have sitting here is the clock, and that's basically just a timer that fires every second and actually gets datetime.now. So we get a stream of clocks. And then finally I'm combining latesting the clock and the values that come back from this web service calls.
Okay.
And so I'm just concatenating those and putting them on the UI. Now, the thing with this piece of code is there's some reuse possible, right? Like I have this total distinct trick that I'm maybe using in all of my UI assets. And I also have this clock setting here, which is like using interval, but I always want to project it onto datetime.now. So what I did is actually move all of that stuff into a class called myExtensions, which is defined in the portable library project. And so here I have getClock and I have tame. Tame is like something that does a total and a distinct. And so, because I found those very useful utilities, and of course I can go further here. I could say like, we're always going to talk to the same web service. So maybe I want to move that other query in there as well. Like I've just moved like 2 pieces here. But so this lives in the portable assembly that's now shared by those 2 applications.
Great.
And so as I execute this, I hope it actually works. Yeah, so that's the WPF app here. As I execute this piece of code and I say hello, like you see after that 250 millisecond plus 500 millisecond throttling, you get something back, you know, whatever this thing means, right? And just to wrap up here and show you some other cool things, so let's actually also do this in the Windows 8 app, right? Like I can just do my extensions over here and also make this code use the same portable core, right? So I'm substituting my clock here and I'm substituting this thing for tame, dot tame of, what was it that I used, time span from milliseconds or from seconds 1/2, right? So now I've made this code also use the same portable assembly in the core. There's still a difference in this query. Here I'm using an async operation because I'm using some WinRT specifics. Here I'm actually, in the other guy, I'm just using a task. So you can have places where things are different, of course. Now one more thing I want to show here is, let me actually set a do, which is just an interception point, in my getClock. Okay? So just to see where the clock is being generated from. And so as I execute this piece of code here, that's the WPF app, and I basically start this guy. Whenever the clock ticks, that do thing fires. And I have a call stack setting here, and it may not be readable enough here, but if you actually would look at this thing, you would actually see at the very bottom, System Reactive Platform Services, Concurrency Abstraction Layer. That's where we actually talk to the underlying platform. And if you look at everything underneath is system.threading.timer stuff. Okay, so that's a .NET specific timer that's actually executing the clock here.
Sure.
So that's a system threading timer. Now let me do exactly the same in my Windows 8 app, right? So this is a portable, again, this is a portable piece of code. It's a portable clock that I can use on any platform, but depending where it runs, it discovers the underlying platform capabilities. And so as I set a breakpoint in the Windows 8 app, and I actually make that the startup project here, and I run this guy, here we go, and I start the app, it's the same app. When I get my breakpoint here, at the very bottom I see the concurrency abstraction layer implementation again, and right underneath there's a native to managed transition. That's actually WinRT generating my timer. So RX is now talking directly to WinRT to run the timer. And so, in fact, you could go one step further to actually really prove this. If I go to the properties and I make this thing a mixed debugging session, so managed and native, and I try to hit the same breakpoint here, you would actually see the call stack having the managed part and the native part. And so, looking back into this guy, at the very bottom you see over here thread pool WinRT. Underneath you see NTDLL kernel 32 and so forth. Yeah. So you basically see Windows sitting right underneath RX here.
Great.
And so the same portable library that doesn't know anything about WinRT or knows anything about .NET for 5 specific APIs has actually discovered this stuff. And that's using that platform services capability. And so you didn't have to notice that platform services appearing anywhere at all. You just included reactive extensions as the extension SDK, it got included for you.
Awesome.
In the NuGet package manager, the same thing happens. So in NuGet you also got, and here you can see it, you actually see this platform services was actually sucked into the WPF app. In the Windows 8 app, you only see reactive extensions. They don't even show the internal structure of the SDK. So if you have concerns like, but RX is now 5 assemblies, trust me, like, in the future model, you only will have a single entry in your Solution Explorer. Because that's the model we're going to. It's like, you want to include an SDK. And internally it may have a structure of like 5 assemblies, a config file, whatever. You just want to see one thing there. Because the framework itself is also like 60 or 70 assemblies now. Like, you don't want to see system.link.expression, system.link.
Agreed.
You just want to see, I have included .NET here. And that contains that whole refactored surface. RX is the same.
Great.
So, yeah.
And it's getting closer and closer to that. Congratulations on V2.
Thanks.
That's huge, man.
Yeah.
And so now I'll take a break, take a vacation, hopefully.
Oh yes, I'm actually taking a vacation last week of August.
Good for you.
Yeah.
Good for you. And then you'll come back and start cranking out 3.
Most likely.
Rock and roll, man.
Good.
Talk to you soon.
Thanks.